Okay, so we've got here algebraic expressions. It's the first bit of A-level maths. 90%, well, all of it is actually GCSE content at level 8, 9. So it'll be useful there as well. So this is what you're going to start with when you start A-level maths. It's a recap of your algebra rules and rules that you're going to use to be able to solve lots of questions. So let's start. The first thing we're going to look at is our index rules. Now, what's an index? So this is when you've got something which is called a base to the power of something else. So for example, if we have x squared, which is something we use a lot, that's x times x. So you can put numbers there. 4 cubed, 4 times 4 times 4. And we've got a few rules. When we've got two things, and these rules only work if the base is the same. So the base, which is this bit here, has to be the same. Like, think about it. If you're ever confused, think back to numbers. If you had 2 squared times 2 cubed, this works because the base is the same. We can use the rules. But if we had 2 squared times 3 to the 4, the base is different. They're two different things. Okay, so when we multiply indices, we're going to add the powers. And this makes sense because if I've got 2 squared times 2 cubed, that's like 2 times 2, which is the 2 squared. And then 2 times 2 times 2, which is the 2 cubed. Multiplying it all together, I've got 3 plus 2, 1, 2, 3, 4, 5 2s. So in the same sort of similar fashion, if you were to divide them, they cancel out top and bottom. And what you're actually doing is you're taking away. Now, if I've got something multiplied or to the power of, I'm multiplying. So this is like saying 2 squared all cubed. So say I had 2 squared all cubed. That means I've got 3 lots of 2 squareds. And each of the 2 squareds is 2. So I get 3 times 2, which is 6. Okay, so these are the first set of rules we're looking at. Anything to the power of 0 is always 1. And the last one is just splitting it out. So you could have 2 things to the power of something. You can split them out separately. Okay, let's use some of these rules. Right, remember these rules are for the indice part. So for example, in this question, we've got numbers first. So we're going to take the number part first. So we've got 6 divided by 3. Nothing special there. They're numbers as we know it. So we're taking the 6 divided by 3 to give us 2. We've got x to the 5 divided by x cubed. Now, remember, the divide rule is you take away. So you're going to get x 5 minus 3, so x squared. So altogether, we've got 2x squared. And of course, you do that in one go. So here, let's try doing it together. So we've got 2 times 3, which is 6. Then we've got r squared times r cubed. Now, here, you're timesing, so you're adding 2 plus 3, which is 5. Right? B to the 7 over B to the 4. So that's a fancy way, if you like, of saying divide. So a fraction just means divide. And when we divide, we take away. So we've got 7 minus 4, which is 3. Right, we've got some more straightforward ones here. You could pause this and try them, and we'll just go through them quickly. So we've got a times sign, so we're going to add them to give us 11. Here we're going to multiply because we've got this rule here. So we'll have a to the 6 times 2a squared. If there's no number in front of something, it means there's just one of them. So 1 times 2 would give you 2. 6 plus 2 would give you 8 because that's the indice bit. Right, no number in front. So 3 divided by 1 is just 3. And then we've got x squared divided by x to the 4. 2 take away 4 is minus 2. Okay. Right, we've got a few more using these rules where we're going to simplify them. Now, if you think about it, the important thing is only one thing on the bottom, which means everything is divided by that. So I can actually split this out and think about it in 2 different bits. And remember, when we've got a fraction, it's actually dividing. So you've got x to the 7 divided by x to the 3. Now, 7 take away 3 is going to give you 4. So here we've got 7, take away 3 to give us 4. And we've got 4, take away 3 to give us 1. Right? So that simplifies to x to the 4 plus x. Okay, so let's take the next one. And if we really wanted to make it look nicer, we could take x outside the bracket and you'd have x cubed plus 1 if you wanted to factorize as well, but we'll do that later, but that's just for completeness sake. Right, next one, we've got 3x squared divided by 2x. And then we've got 6x to the 5 divided by 2x. 3 divided by 2, if we were in decimals, that's 1.5, but in pure maths, so we're just going to leave it as a fraction. Then we've got x squared divided by x. So that's just the x to the 1. 2 take away 1 is 1, so x. Then we've got 6 divided by 2 to give us 3. 5 take away 1, which is 4. Right, again, you could take something out if you needed to. Right, last one here. So we're going to say everything on the top is divided by whatever's on the bottom. I'm going to separate it out first. Do the numbers first. 20 divided by 5 to give us 4. And then we've got x. And then we've got 7 divided x to the 7 divided by x to the 2. So we're doing 7 take away 2 to give us 5. 15 divided by 5 to give us 3. And we're going to have x because we're going to have 3 minus 2. All right, so I hope that makes sense. I've done it quite quickly, but there should be revision of rules that you've done before. Okay, let's look at negative indices. So what negative, you see a minus sign and your brain is going to go, if it's in the power, 1 over. All right, now you don't need to worry too much about this, but let's think about this as like a rule, right? So if we've got x, a to the minus n. So how do we get a minus number? Well, we take it away from something. So this could be like me saying 0, right? A to the 0 minus n, because we're taking away the n from nothing, which if we go backwards from our division rule, it's the same as a to the 0 divided by a to the minus n. Sorry, divided by just a to the n. Sorry. But when you divide, you take away. Right, a to the 0. Anything to the power of 0 is always 1. So that's going to be 1. And we're going to divide that by a to the n. And remember, the way you would write a divide sign is to write something as a fraction. And so you've proved that rule. You don't actually need this. It's just if it's interesting to you. So you're going to see this minus sign and your brain is going to go underneath denominator. So if you've got 8 to the minus 3, your brain is going 1 over 8 cubed, right? And then in your calculator, you could put 8 cubed in, although to be honest, if you put 8 to the power of minus 3 into your calculator, it will give it to you anyway. So 512. And here you'd have 1 over, because I see that minus, 5 squared. So if you like, the 1 over gets rid of that negative sign as the power and it goes underneath. So you'd have 1 over 25. So that's your, what we say, so that's your negative indices. So we've got our rules for adding, subtracting, and now we've got a negative. The next one is the one that's practiced a lot and is a bit trickier. And it's when you've got a fraction, which is a square root. So if you want to think about this, or if you want to say proof is more to prove it to yourself that it works. So if I had a to the half, which I'm telling you is a square root of a, but if I was going to say I was going to do that and I'm going to square it, well, that's the same as a to the half times by a to the half. And what we know that is we add them up, which will give us a to the 1, which is just a. So then to go back, I'm going to have to take the square root because I squared it initially. So that proves to me that a to the half is the same as the square root of a. Okay, and in the same way, you can look at the cubic and to the, then, you know, a cubed. So, and then the cube root gives you a to the power of a third. Now let's think about it totally theoretically. If we've got a to the, so this is like saying, let's think of a number. Say I said we were going to do 4 to the power of 3 over 2. Okay. And what we're trying to say that's the same as is 4 to the power of a half, right? Cubed, because then we can multiply it out. So we get 2 cubed and we 2 cubed and we would get 8 because 4 to the half is a square root of 4. So you've got a to the m over n, and you wanted to write out, but I'll write you out the proof just so you've got it for, like I said, completeness sake. It's the same as a to the m times 1 over n, which is the same as a to the m to the 1 over n, which we know a to the m is just a to the power of something, and the 1 over n gives you the nth root. And we could write it the other way around to get the other example. But essentially, your calculator will do it if it's a number. You need to make sure you understand it so you can do it if it's an indice. So we've got find the following as fractions or whole numbers. So 25 to the power of a half is the square root of 25, because we're using that rule. So that's just going to be 5. Next one, we've seen a minus sign. We see a minus sign, immediately our brain goes 1 over, and we get rid of the minus sign. And then what's 9 to the half? That's the square root of 9, which is 3. So we'll have a third. Another minus sign. I shouldn't get so excited about minus signs, but another minus sign. So I'm going 1 over 25 to the half. I already did 25 to the half, and I got 5. So it'll be 1 over 5. Again, a minus sign. I have 4 to the minus 5 over 2. So that minus means I've got 1 over 4 to the 5 over 2. I know that means I can take the square root first. So I'm going to do 1 over the square root of 4, because that's what that 2 tells me, all to the power of 5. So 1 over 2 to the 5. And yeah, you have so you'd end up with 1 over 2 to the 5, which you can calculate if you choose to. But obviously, you should know that's 32. But if you don't, it's not a problem either. Okay, next one. 1 over a fraction. So I see a minus. I know I want to do 1 over. Now, what happens when you divide a fraction by 1? So think about it. If I have 1 over any fraction, say 3 over 2, that's saying 1 divided by 3 over 2. And I know that my rules for fractions is kiss and flip. So change the divide to a times, flip over. So when I divide any fraction by 1, what I'm doing to it is flipping it. So that minus, if it's a fraction, flips that fraction over. And that's to the power of 2/3. Okay, and then I'm going to do the bottom bit first, which is the cube root, because it's like saying 512, 343 to the 3rd, and then squared. So the cube root of 512 over 343 is 8/7. And then all of that is squared. So we end up with having 8 squared. And remember, when it's a fraction, you do something to the top, you do it to the bottom as well. So I took the cube root of 512 and the cube root of 343. So 8 squared gives me 64, 7 squared gives me 49. Right, we've got another example. This is quite useful. This will become useful when you'll see exam questions and you'll understand why we've put these in there. So we've got 625 as a power of 5. Now, you don't necessarily need to know these, but you may do 5 to the 4. And if you didn't, you could do 5 squared, 5 cubed, and then 5 to the 4, and you'd find it works. 1. Anything to the power of 0 is 1. Here, I can see a 1 over. So instantly, I know it's a minus. Then I'm thinking 5 cubed is 125. Right, so I've got 5 root 5. Now, 5, this is the same as, if I was to split this up, 5 to the power of 1 multiplied by the square root of 5, which I know is a half. Now, when we multiply, we add indices. So 1 plus a half. So we get 5 to the 3 over 2. So when you've got something weird like that, you've got to think about it and split it up. Okay. There's a few more examples here. I'm just going to complete them quickly for you and write the solutions out. I think these are from actually the Edexcel textbook, so you may have come across them, but pause it, go through them. If there's a problem with any of them, put it in the comments and I'll happily go through it. But these are literally just for you to double check that this has made sense to you. So if you're not getting these answers, then make sure you check them. So if you're not sure of what you're doing here, think about splitting it. If the question is decimals, you can leave the answers in decimals. However, if the question is in doesn't generally stick to fractions. All right, here's another example from the book. You've got, given that y equals 1 over 16 x squared, they want you to express it in that form. So what they're trying to say is you're replacing the y with this. So if I replace the y, I've got 1 over 16 x squared, all to the power of a half. Now remember, it's everything to the half. Numbers I treat as normal, but a half means square root. So 1 over 16 square rooted. So I would treat each bit differently. And I would then have x squared to the half. So 1 over 16, the square root of it is going to give me a quarter because I square root the top and the bottom. And then here I'm going to multiply, which will just leave me with x. And now that's in that form where you can see your k is a quarter and your n would be 1. Right, let's do this one. So we've got 4. Instead of y, I'm writing 1 over 16 x squared to the minus 1. Now remember, to the minus 1 means you do 1 over. But before we do that with a number, we're going to do, well, this is the same as 4 times 1 over 16 to the minus 1 times x squared to the minus 1. Right, so the 4 stays the same. 1 over 16, remember, with a fraction, all it does is flip it. And here we can multiply these two. So I'm going to get 2 times minus 1, which is minus 2. And then if I put it all together, 16 times 4 gives me 64, x to the minus 2. So I could say k is 64 and n is minus 2. So that's indices. You'll all have like questions that will have lots of like, you'll have examples, sorry, in your textbook, which have lots of questions in them. And then at the end of this chapter, we've got exam questions where it's tested. And as we do more topics, you'll see the exam questions build, eventually getting you to a point that you can go through a whole paper. Right, so we're now going to expand some brackets. So expanding brackets means everything inside is multiplied by what's outside. So we've got minus 3 multiplied by 7x. So you're going to do minus 3 times 7 to give you minus 21. X times x, x to the 1 times x to the 1, which is just going to give you x squared. And then I've got minus 3 times by minus 4. Remember that the sign in the front is what you're multiplying by. So plus 12x. Okay. Y squared times what? 3. So you get 3y squared. Y squared times minus 2y cubed. So I've got to put minus there. And I'm going to get 2y and then to the power of 5, because remember we're timesing, which is the same as adding in indice world. Okay. 4x times 3x gives me 12x squared. 4 times minus 2 gives me minus 8. X times x squared gives me x cubed. 5 times 4 is going to give me 20. X times x cubed is going to give me x to the power of 4. And so I've got 20. Oh, sorry, 5 times 4 over 40, I mean 20. There we go, let's change that. 20 x to the 4. Right, this one here. 2 times 5 to give you 10 x squared plus 6x. Now this is, be careful here, everything is multiplied by minus 5. So it's minus 5 times 2. So minus 10x, and then minus 5 times 3. So minus 15. And if I look at that, these two I can simplify together and giving me minus 4x minus 15. Right. We've got some more questions here. And these are, it depends how you want to do them. I would typically, if you've got x outside and then 2 brackets, is open the double bracket first. So remember, it's 2x times x to give you 2x squared. You've got 2x times minus 7 to give you minus 14x. So remember, everything in the first bracket multiplied by everything in the second bracket. 3 times x, 3 times minus 7. And then you can multiply everything by x. So you get 2x cubed minus 14x squared plus 3x squared minus 21x. You could have simplified the x's together earlier. I'm going to simplify it here, where I'll get minus 11x squared minus 21x. Okay, in a similar fashion, I would do the same with f, but can you see there's x's and y's there? Don't let it confuse you. It's the same concept. So we'll leave the x outside for the moment. You're going to have 5x multiplied by 2x. So you've got 10x squared. Then you're going to take that same 5x and you're multiplying it by minus y. So you're taking the first number and multiplying it by everything in the bracket. If you find it easier, let's do this and then I'll show you how you could lay it out. Minus 5xi, 5x times 4 to give you plus 20x. Now, everything in that second bracket is being multiplied by minus 3. So now we're going to take minus 3y and multiply it by 2x, minus 3y and multiply it by minus y, and minus 3y and multiply it by 4. So we're going to get minus 3 times 2, which is 6, yx, because it, and we normally write xy just because it looks prettier. Minus and minus make a plus, 3y squared minus 12y. Okay, so that looks a little bit messy, but it's fine. And then you're going to see if we can combine anything. We have a look. That's the xy term. That's also an xy term. And do we have anything else that's the same? No, the only things we can combine are the xy term. So we've got minus 5, minus 6. Remember, the sign in front always goes with it. So we'll have 10x squared minus 11xy plus 20x plus 3y minus 12y squared. Oh, no, that's the wrong way around. Sorry. You do things too quickly. Right, now you're going to multiply everything by x. So you'll get 10x cubed minus 11x squared y plus 20x squared plus 3xy squared, or you could write 3y squared x, it doesn't matter, minus 12xy. And that would be your final answer. Now, if you were struggling to open out this bit, another way that you could write it is you could have written 5x multiplied by that, because we're used to opening single brackets, minus 3y multiplied by that, and join them together. It's the same thing. If it helps you see it, then that might be a sensible way to do it. Okay. Right, so this one's a bit mean because we've got a fraction in there. So what we're going to do with this one is we're going to take x minus a half squared. So when we square something, there is sort of like a shortcut where you square the first number, you can square the last number, multiply them together and double it. Let's see, but let's go through it. So this really means x minus a half, x minus a half. So what you're actually doing here is, and we'll do x plus 4. So let's do that bit first. X times x to give you x squared. X times minus a half to give you minus a half x. And then you're taking, oops, let's do those arrows properly. Okay, so you've got x times x, x squared. Then that same x multiplied by minus a half. Then you're multiplying everything by the minus a half x. You get another one. And then minus and a minus make a plus for that last one. And we'll get 1 over 4. Right, so I'm going to simplify that. And I'm going to get x squared minus a half is going to give me minus 1 plus a quarter. Right, now I'm going to multiply everything by x. And that's going to give me x cubed. So I'm timesing everything by x minus x squared plus a quarter x. And now I'm going to multiply everything by 4. So I'm going to get plus 4x squared minus 4x. And 4 times a quarter is just going to give me 1. Now I want to put like terms together. So I've only got 1x cubed. I've got minus x squared and plus 4x squared. So I get plus 3x squared. I've got 1/4. So a quarter minus 4, which is going to give me minus 3 3/4, which is minus 15/4 plus 1. Okay, the last one. Now, later on in this this series, you learn how to open things which are to other powers. But for the moment, cubed means I'm multiplying it 3 times. So, and we're going to use the same strategy. You're going to open out the second 2 first. So, and I'm going to show you how I would open something which is squared, because essentially this bit here is 7x plus 4y squared. So the way I would do that is take the first one and square it. So 7x squared, I'd square the 7 to give me 49, and then you've got x squared. Then what you're going to do is you're going to multiply the 2 numbers in the middle. So 7 times 4 to give you 28, and then you're going to double it. So double 20, which gives you 40, double 8, which gives you 16, add it together, gives you 56, xy. Then you're going to square the last number. So 4 squared is 16, and then you've got y squared. So that's if you wanted to do it quicker, you could multiply it all out in the way that you're used to. And then we multiply everything by 7x. So we've got 49 times 7 to give us 343, and that's going to be x cubed, because you've got x squared times x. We've got 56 times 7, which is 392, and then you've got x times x, x squared y. 16 times 7, which is 112. I'm not sure why I chose this one. And it's going to be y squared x. I really should put x, y squared, but it's all good. Now I'm going to multiply everything by 4y. So I've got 49 times 4 to give me 196 x squared y. I've got 56 times 4 to give me 224 xy squared. 16 times 4 to give me 64 y cubed. Right, now we're going to put like terms together. We should just do this for completeness sake. And let me have a look at my like terms. I've got only one lot of x squared y. I've got x squared y here, which is the same as that one. And then I've got y squared x, which is the same as xy squared. Right, so I can combine those. So I've got 343 x cubed plus 392 plus 196, which is 588 x squared y, plus 112 plus 224, so 336 xy squared plus 64 y cubed. Right, I know that was very long, but hopefully you get the gist of it, and it's opening out all those brackets. Now, the opposite of opening out brackets is to factorize. So essentially, to put things back into brackets. So if I've only got 2 things, that's really straightforward. So all I'm looking at there is I'm saying to myself, what goes into 7 and into 21? Well, it's going to be 7. What do I times 7 by to get 7x? It's just x minus 3. Right, so now we've got 2y squared plus 10y. So I look at the numbers first. What goes into 2 and 10 will be 2. Y squared and y will be y. So I'll get y plus 5. Because I want to say, how would I open it out? So if your expanding is quite strong, then factorizing will be easy. Right. We've got 18 and we've got 60. So what goes into 18 and into 60? Well, 6. And if you hadn't got that and done 2 to start with, you would slowly have realized there's still things in the brackets. And we still might be able to do something. So we've got 6. 18 will be 3. Oh, I didn't look at the others. See, this is what you shouldn't do, or you could do, but you'd have to do it in steps. So first the numbers, which we said was 6, then x squareds and x. So what's the smallest amount that would go in both would be 1 lot of x, and then y and y squared would be 1 lot of y. So now I'm going to say to myself, 6 times 3 gives me the 18. I've already got 1 x, I need another x, and I've got the y. 6 times 10 gives me 60. I've got the x and I've got the y, so I need a y on the outside. Now, if you did that, and you might have done it in steps, like I almost did, you would find that the bracket, there was still something common to take out, and you just do another step. Right, what goes into 9 and 3 is 3, and we're going to have 3x squared. So we'll have 3x plus 1. So we need 1 because when we open it out, we still want to end up with 3x squared. Okay, the next rule you'll have come across if you've done GCSE, or if you haven't, you'll be doing GCSE, and it's the difference of 2 squares. This is so important. Right, difference is the key bit. Difference, takeaway. There has to be a takeaway sign between 2 things, and either side are going to be things that you take the square root of. So the square root of x is just x, and the square root of 25 is 5. What you're going to do is you've got 2 brackets, and then you make 1 plus, 1 minus. So again, 2 brackets. X squared is x, 9. We've got 3, but there's a minus in the middle. So we do plus and minus, and it does that. Now, the reason this works, let's open out this. We've got x times x, x squared. X times minus 5, minus 5x. 5 times x plus 5x. Plus times a minus is a minus. And you'll notice these 2 cancel each other out because there's that minus sign, right? So 2 brackets again. We know it's a difference of 2 squares. Square root of 4 is 2. Square root of x squared is x. Square root of 9 is 3, y. So then we write it again. Make 1 plus, make 1 minus. And in a similar fashion, that last one, you've got square root of 81, which will be 9. Square root of 169, which gives you 13. Yes, you got 13x and 13y. Sorry, 9x and 13y, and a plus and a minus. Right. I know I've talked really fast through that, but if you have a look at the difference of 2 squares, it should make sense. You're literally following that rule. Okay, let's factorize. Okay, there's lots of ways to factorize, and everybody does it differently. Essentially, you're looking for 2 numbers that multiply to give you the last one and add to give you the one in the middle. Now, all of you should have a class whiz calculator. You can use that to help you factorize if you need to show the factorization, but you really should have come across these through school. So if it's x squared on its own, it's always x and x. And now I look for factors of 6. So I look at the last number and I think, okay, how can I get 6? 6 and 1, 2 and 3. How can I get minus 5 from that? Well, I'll need minus 6, add 1. All right, so do that again. X and x. I've got 8. I've got 8 and 1, 2 and 4. How can I get 6? Well, if you can see, it's just 4 plus 2. So plus 2 and plus 4. Okay. These are a little trickier. There is a video on the channel, which I'll make sure I link, where I go through quite slowly different methods to do this. All right, so my favored method, which I think is when you multiply. So this is your coefficient is not x. So I would do 2, the first one times the last one. So you do 2 times minus 3. So you get minus 6. And now you're going to say, how can I write minus 6 as its factors to make plus 5? So, well, we'll have 2x squared minus 6x plus 1x. Would that, oh, sorry, that's going to give me minus 5, not plus 5. So let's do that again. Sorry. So I want the factors of minus 6. So, and I want plus 5. So I'd have to have Let's think, what will I have to have in order to get that? So I've got -6 and 1. I'm going to have 1, -1 and 6, which makes more sense. So I've got +6x minus x minus 3. Okay, so I read it wrong to start with, and so you can see that works. Then I'm going to just take these two, and I'm going to factorize that. So I'm going to say what goes into 2 and 6 is going to be 2, and I'm going to have an x, and that's going to give me x plus 3. And then whatever's in the bracket here, I write again. And then I say to myself, what would I have to put outside to give me that -x minus 3? I'd have to put -1. So now I have my two brackets. I have one of them being x plus 3, and then the other one is the numbers on the outside. Okay, so let's do that again slowly, hopefully without messing this up. So 6 times -10 to give you -60. Factors of -60, when you add them together, gives you 11. So you could have, well, we know it's not going to be 60 and 1 because that's really big. 2 and 30, nowhere near it. So we think, how do we get 60? So I could do 60 divided by 5 would give you 12 and 5. Okay, so we're still not at 11. What other numbers have we got? We've got 6 and we've got 10. So it could be +6 minus 10 or -10 plus 6, right? You could think of some other factors as well. You've got 3 and 20. So +3 minus 20, 20. I know you're probably shouting at the screen what it is. But that's the method, and that's what's going through your head while you're doing this. Okay. And so you can either systematically work through it, or if you see it, you can say, well, we've got +15 and then -4, or we could have -15 and +4. Now we want -11, so it's going to be this combination. So I replace the -11x with 6x squared minus 15x plus 4x minus 10. I take the first two numbers and I factorize. Well, 3 goes into both of them, and so does x. And that leaves me with 2x minus 5. I write 2x minus 5, and I can see I've got to do a +2. So the reason I've shown you all those factors is to show you, yes, your brain's going to go off and you can think about it. And you might say to yourself, I know an easier way to do this, whatever method you've learned. Now, in an exam, if they ask you to show everything, but I know that if I put this into my calculator, so if I put this into my class whiz, it will give me the answers. So it tells me x equals 5/2 if it equals 0, and x equals -2/3. If I wanted to work backwards from that to get my brackets, what you're going to do is you're going to rearrange that to make it equal to 0. So I multiply the 2 up. So 2x equals 5, and then I minus the 5 to make it equal 0. And I could sort of work backwards and show my brackets, particularly if you went sort of blank in an exam and really were like sort of thinking about it and couldn't work out where it comes from. Okay, we're going to look at surds now. Now, surds are numbers under a square root which don't come out exactly. They're a type of irrational number. So a rational number is when you have one number divided by a number, and you can write it as what we say a over b, or as a fraction, where both numbers are in the simplest form. Now, you can't do that with surds. They're a type of irrational number. So it's where you have like √2, √3, numbers that you can't split out any further. Okay, so let's look at some questions. There are only 3 rules. They're up here. We'll refer to them. Essentially, they say if you've got something like this, you can split it out. You can do the top and you can do the bottom. So you've got the square root of 9 being 3, and the square root of 25 is 5. For B, that looks a little bit complicated, but let me try split that out. So that would be the same as saying the square root of 16 divided by 1, 2, 3, 4. So I need 4 zeros. So 10,000. The square root of 16 is 4. The square root of 10,000 will be 100. So that's 2 over 50. I can half it again, 1 over 25. Okay, so the next one, I can put both root 2 and root 8 together underneath. So I'm using this rule here. So that's the same as 2 times 8, which is 16, which I know to be 4. And then I've got root 3 times root 3 is just going to be root 3 times 3, which is 9, which is 3. So anyway, root anything. So root a gazillion, root banana times root banana will be banana. Anything underneath the square root, if you multiply it by itself, you're going to go back to the original because you're effectively squaring it. Right, if we've got numbers and we want to simplify them, we're essentially using that rule where you've got, so the rule where we've got root AB is root A times root B. So we're going to think 18, can I divide that by something that has an exact square root? So yeah, I can do it by 9, can't I? So I'll have root 9 times root 2, because we know that 18 is 9 times 2. Then we can split it up. Root 9 is 3, and so we'll get 3 root 2. Now, in the same way with indices, the same way you do algebra, things have to be the same in order to be able to simplify them. So if I wanted to do root 18, I'm saying to myself, what goes into 18? Well, we did that above, which is a square root. We've got this. We've got 3 root 2. Okay, and we're going to say, okay, can we do the same with 72? So we're like 72 divided by 2 is 36. So we've got 36 times 2. So then the root, and remember, we can split this further to be root 36 times root 2. Root of 36 is 6. So we get 3 root 2 plus 6k root 2. Now, if the k wasn't there, we just add them up and we get 9. But because we've got k there, I guess we could take root 2 outside a bracket and we get 3 plus 6k. I'm not quite sure why the k is there. So let's pretend the k is not there. And if we'd had root 18 plus root 72, you would get 3 root 2 plus 6 root 2, which is 9 root 2, which you'll also find is what your calculator will give you. Right. We've got a few to expand. So this is putting together all those rules that we have. So we've got our brackets, and we've got, we're opening out our brackets and we're using our surds. So we've got root 2 times 5. So you've got root 2 times 5 minus root 2 times root 3. So that's going to be A, right? So minus, yes, so that minus goes with that root 2. I think that makes sense. Okay, so we've got 5 root 2 minus root 2 times root 3, which is just going to be root 6. And we can't simplify that because they're two separate bits. Let's have a look at B. We've got 2 times 4 to give you 8. 2 times 2 root 5. So remember the numbers we can multiply to give you 4 root 5. Root 5 times 4 to give you 4 root 5 again. And then root 5 times 2 root 5. So let's write that out here. Now remember, if it doesn't have a number in front, it's like it's a 1. And then remember, root 5 times root 5 is 5. So we end up with 2 times 5. So we end up with 10. And then what we've got there is 18 plus 8 root 5. Okay. What I'm going to let you do is, if you have a look at that last one there and try that one, and I'll write out the answer and you can double check that that's what you get. So you've got 5 minus 5 root 3, sorry, minus root 3, minus and a minus makes a plus. So 8 minus 6 root 3. Okay. Now this is the last bit, and you should have come across this before, and it's called rationalizing the denominator. Now this is where everything that you've done, you've got your difference of 2 squares. So if the denominator has a plus 2 things in it, we're going to be using the difference of 2 squares. Otherwise, we're just going to be using the fact when you do root something times root something, you get rid of it. So rationalizing means we're getting rid of the surd on the bottom. We don't want it on the bottom. Okay, so we don't want that root 11 on the bottom. What we're going to do is multiply the top and the bottom by root 11, because if we multiply it by the same thing, it's the same as multiplying by 1, which doesn't change anything. So 1 times root 11 is root 11. Root 11 times root 11 is just 11. And those are the same things. Now you'll notice, try in your calculator, do 1 over root 11, it will rewrite it for you as root 11 over 11. Okay, here we've got a plus and we've got two things. So your rule, if there's a plus there, is to rewrite it, the two numbers, but with a minus in the middle. And that's because, remember the rule, a squared minus b squared, a plus b, a minus b. So here we can say, well, our a is 3, 3 squared is 3, and we'll be able to multiply them. So on the bottom, you'll have a is 3, 3 squared is 3, 3 squared is 9, root 11 squared is just 11, and there's a minus sign between them, always. Okay? And on the top, remember this means 11 multiplied by all of this, which is why if you always write it in a bracket, you're not going to confuse yourself. 11 times 3, 33. 11 times root 11 is going to give me minus 11 root 11. Okay. Then we've got 9 minus 11, which is going to give you minus 2. So you have 33 minus 11 root 11 over minus 2. That doesn't look very pretty, but that's the answer. That's the other thing you need to get used to with A-level. You won't get answers that look nice. So you're going to look at them and you're going to assume you've done something wrong. Right, so here we're going to multiply top and bottom by 3 plus root 5 because we've got minus there. So we're going to change the sign. Okay, and because we've got two things on the top as well, I'm just going to put brackets around everything so I don't confuse myself. Let's do the bottom first because it's easy. Square the first number minus squaring the second number. And on the top, we've got 14 times 3 to give us 42. 14 times root 5 to give us 14 root 5. 2 root 5 times 3 to give us 6 root 5. And then remember here, you've got 2 root 5 times root 5. Root 5 times root 5 make 5. Times the 2 give you 10. And so you're going to get 52, 14 plus 6 to give you 20 root 5 over 4. And then you're going to say to yourself, can I divide everything by the same number? So 52 goes into 4 13 times, and 20 goes into 4 5 times. So 5 root 5. I mean, if you want to see that, that's essentially splitting it like that, using that bits that we did right at the beginning. Okay. Right, part D, I've got 1 over root 3 squared. It's like, oh, that doesn't look nice, does it? All right, let's do it step by step. I'm going to take this bit and square it. So remember, that's the same as, okay, which is going to give me the first number squared, which we said was 1, root 3 squared, which is 3. And so we're going to get, yeah, root 3 squared, and remember it's always plus, and then double the middle, so minus 2 root 3. Now, if I simplify that, that's the same as saying 4 minus 2 root 3. There's still something on the bottom. We don't want a root on the bottom. So now we get to use that rule. So we're going to multiply top and bottom by 4 plus 2 root 3. The top doesn't change. Well, as in there's nothing to times it by, just 1, so it's by itself. And on the bottom, we're going to have the square of the first number, which is 16, minus 2 root 3 squared. So 2 times 2 gives me 4. Root 3 times root 3 gives me 3. 4 times 3 gives me 12. So I get 4 plus 2 root 3 over 4. Now that's the same as 4 over 4 plus 2 root 3 over 4, which we could simplify further to give me 4 over 4, which is 1 plus root 3 over 2 if I wanted to keep it separate. Alternatively, I could have just divided all of these by 2, and I would be left with 2 plus root 3 over 2 if I wanted to write it as one fraction. It kind of depends how the questions are worded. Okay, so hope that's been useful. Now there is the next video, which will be exam questions on this topic. It should play straight after. So have a look at those and see how you get on.